Right. So, actually we were in the 70th question. Right. So, we have to use the concept of confidence interval or the confidence uh, interval estimation, right? And the concept of margin of error. So, therefore, first we need to identify key information. First thing is the margin of error. So, in this problem, we can identify the margin of error is 0.1. Then the alpha value or the significance level. So you know that 95% is the 1 minus alpha, that is the confidence level. Then the alpha is 1 minus 0.95, that is 0.05. And also in this case, population variance is known. So therefore, you know the value for sigma squared, that is 0.25. And based on the confidence interval, we can identify a small mathematical relationship between the margin of error and these measurements. That is, since we have to use the Z distribution, Z alpha divided by 2 sigma squared over n. Also, you need to know the value for the n, right? So actually, in this case, we are going to find the value for the n. So therefore, you don't know the n. So therefore, we need to calculate the value for the n. And here is square root. This is equal to the margin of error. So normally we denote margin of error by simple d. So now we can substitute the values, right? Now we can substitute the values. So Z alpha divided by 2 means Z 0.025. So you know these values, right? Z 0.025 means 1.96. Again, then we have to හුරුයි නේද? Z alpha බෙදීම 2.02.5 වෙනකොට Z value එක 1.96. So therefore you can plug that value to here as 1.96. Then sigma squared is 0.25 divided by simple n square root of whole part. Then the value for d is 0.1. So now you need to apply little bit mathematics, right? So here you can square. I can take 1.96 into other side as 0.1 divided by 1.96, and you can take the square of this fraction. Here only you have now 0.25 divided by simple n. So now you can only stay in or keep in n in this side, and you can take all other values into the other side, and finally you have the answer 96.04. So this is a number, it means count or the number of sample size. So therefore it should be a integer number. So therefore you have to round up it as 97. Right. So so here you can find the answer, right? You can find the fourth choice is the 97. So that is how we can do this type of question using the relationship between the margin of error and the confidence interval. So normally you may have to calculate simple n, or in some cases you may have to calculate sigma squared, or you can calculate any of the value based on this relationship. Right. Let's move to the next question. 81. So it is also a type of question that we discussed earlier. So there are three statements. Among those three statements, you have to identify the correct statements, right? Which of the following statements are true about confidence interval? So regarding the confidence interval, you need to check whether the statements are correct or incorrect. So let's consider the first statement. The width of a confidence interval increases as confidence level decreases. So the width of a confidence interval. Confidence interval එකක width එකයි confidence level එක අතර තියෙන relationship. So normally when the confidence level decreases, the width of the confidence interval also decreases. There is a positive relationship between the width of the confidence interval and the confidence level. සාමාන්‍යයෙන් confidence level එක උඩා වෙනකොට decrease වෙනකොට confidence interval එකේ width එකත් decrease වෙනවා. So that is the relationship between width of a confidence interval and the confidence level. So therefore, first statement is incorrect. Then the statement B, confidence intervals can be used to test some hypothesis. Yes, it is correct. So you know that normally we can do a hypothesis testing using three ways. There are three ways of doing hypothesis testing. First way is using test statistic and critical region or acceptance region. අපි test statistic එකක් calculate කරලා acceptance region එකේද critical region එකේද වැටෙන්නේ කියලා බලලා hypothesis test කරන්න පුළුවන්. Also we can use the p value or the p approach. නේද? p value එක calculate කරලා alpha එක්ක compare කරලා we can test hypothesis. As well as we can use confidence intervals for testing hypothesis, but not every time. The අනිත් දෙකම හැම අවස්ථාවකදීම පුළුවන්. එක්ක ටෙස්ට් ස්ටැටිස්ටික් එක එහෙමත් නැත්නම් p value එක ඕනම hypothesis එකකදී ටෙස්ට් කරන්න පාවිච්චි කරන්න පුළුවන්. But confidence intervals can be used to test some hypothesis. So therefore, statement B is an accurate statement. නිසා B හරි. දැන් මෙතන නිකන් හරි sum තිබ්බේ නැත්තම් මොන පොඩ්ඩක් problematic වෙනවා. Consider the statement C. For small samples, the width of the confidence intervals based on P distribution is larger than the width of the confidence intervals based on Z distribution. It is correct. It is correct. Because we know that T distribution has more variation than Z distribution. නේද? අපි දන්නවනේ Z ට වඩා T ගේ spread එක වැඩිනේ. එතකොට යාගේ confidence එකේ width එක වැඩි වෙනවා. So therefore right. So statement C is also correct. So there is a question. that asks what are the cases that confidence intervals can't be used to test hypothesis. So there are some cases in your syllabus. You have to test the hypothesis for the population proportions, right? Population proportion එකට ඔයාලා test කරන ඕන hypothesis නේද? H naught pi. Pi is the population proportion. Pi equal pi naught. When you test this kind of hypothesis, when you calculate the variance of p, then මේ hypothesis එක test කරන අවස්ථාවේදී ඔයාලට variance එක calculate කරන්න වෙනවනේ මේ මේකට පාවිච්චි කරන estimate එකේ. ඒ වෙලාවේදී you use the hypothesized value. ඔයා පාවිච්චි කරන්නේ මේ hypothesized value. හරි. පොඩක් මේකේ materials අරගෙන බලන්න මේ හරියදී. When you are doing hypothesis testing for population proportions, you use hypothesized proportion values in order to calculate the variance of your estimate. So based on this, you perform the hypothesis test. The similar test can you perform with the confidence interval? මේ ටෙස්ට් එක මේ විදිහට මෙයාට කරන්න පුළුවන් confidence interval පාවිච්චි කරලා. What බෑ. Why? Because there is no hypothesized population proportion. දැන් confidence interval හදන්න ගියාම මෙහෙම hypothesized proportion එකක් දෙන්නේ නැහැ නේ කවුරු. So therefore you can't use the method of confidence interval in testing such hypothesis. Population proportion එකේ මේ වගේ අවස්ථාවකදී ඔයාලට hypothesis එක test කරන්න confidence interval පාවිච්චි කරන්න බෑ. Confidence interval පාවිච්චි කරන්න. Likewise, there are some cases you can't use confidence intervals to test the hypothesis. Right? Right. Okay. So the answer is here. So only B and C are correct. B, C විතරයිනේ හරි. Yes. So therefore the answer is 4. හතර තමයි උත්තරය. Right. හරිනේ එක නේද? හරි. එහෙනම් අපි යමු 19ට. 19. Again we have to do some calculations. Yes. So here a sample of size 25 is taken from a normal population. The sample mean and the sample variance are calculated as 15 and 16 respectively. What is the upper limit of the 95% confidence interval for the population mean mu? So here you need to know the construction of confidence intervals. නේද? Confidence intervals හදන විදිය ගැන ආට අවබෝධයක් තියෙන්න ඕන. So yes, the distribution is normal, but the sample size is 25. So sample size is 25 and the population variance sigma squared is unknown. The population variance එක දීලා නැහැ. Instead of that, you have given x bar as 15, variance s squared as 60, and the confidence level is 95%. So with the small sample size and unknown population variance, you have to use T distribution for constructing confidence interval. Right? So therefore, you have to take x bar minus or plus T distribution, alpha divided by 2, and the degree of freedom n minus 1. Here, you can't use population variance. Instead of that, you have to use sample variance S squared divided by simple n and square root of the whole part. So now you can substitute values. So x bar is 15 plus or minus T alpha divided by n minus 1. So you need to calculate the T value from the T table. So here alpha divided by 2 means 0.025, n minus 1. So there are 25 items, 24. 24 minus 1 is 24. So the degree of freedom is 24. So you can find the T value from the T table, right? The T value same, then T table sorting water balaneka game up. So the value is 2.06. And you can substitute that value here, 2.06. And S squared is 16, n is 25, and take the square root of whole part. So here they ask only the upper limit, right? That means you just need to consider only the plus, no need to consider minus. So 15 plus 2.06, 16 over 25 square root of whole part. And you can then now simplify your answers. 15 plus, if you simplify further this part, the answer should be 1.61. So the final answer should be 16.65. So is there any answer like that? Yes, fourth one. So very easy, right? So exactly you can do the calculation. Answer is in your answer script. So you just need to figure out that. හරිනේ. හරියට calculation එක කරනවා නම් උත්තරය හරියට ලැබෙනවා. right. ඒ නිසා මේව practice කරන්න හොඳට කාලය අරගෙන concept එක හොඳට ඔළුවට දාගන්න. Then practice. Because time is also a matter. When you are doing your MCQ paper, time is also a matter. නේද? time එකත් එක fact එකක්. right? So you need to speed up as much as possible. Then only you can get a good result from the MCQ part. Why speed එකත් වැඩි කරගන්න ඕනේ මේ questions කරන්න. ඒකට practice එක අවශ්‍යයි. Right. Now we can move to the 20th question in your model paper. It is also a calculation one. The lifetime of a certain type of light bulb is known to have a standard deviation of 14 hours. How large a sample should be taken if it is desired to have a margin of error of 10 hours or less at 95 level of confidence? So this is also same as the earlier one. So earlier we done a problem in relation to the margin of error and the sample size. So this is also same as that. Here, the population standard deviation is known. So therefore, you can use Z distribution. And the margin of error is 10 or less than that. That is one difference. The margin of error එක හරියටම 10 නෙමෙයි කියන්නේ 10 හෝ ඊට වඩා කුඩයි. So you can consider the statement that we earlier considered. So here 95% mean is at 0.05. And you have given the standard deviation that is 40. And it is standard deviation, right? and here square root of n. So this is less than or equal 10. So that is the statement. So if you can write this statement correctly, then little bit mathematics you have to done. Maths පොඩ්ඩයි තියෙන ඊට පස්සේ. Here 1.96 40 over square root of n less than or equal 10. Here 1 over square root of n equal to 10 divided by 40 into 1.96. හරිද? අපිට මේක සිම්ප්ලිෆයි කරන්න පුළුවන්. Here 1 over මේ ටික ඔක්කොගෙම සුළු කිරීම එන්නේ 0.1276 less than or equal square root of n. So now you can square both sides. Then the answer is n less than or equal 60. It means the minimum sample size is 62. So based on the margin of error, you can easily calculate the value point. එච්චර අමාරු question එකක් නෙවෙයි. හරි. Margin of error කියන concept එකත් එක්ක යන lazy maths ටිකක් තියෙන question එකක්. හරි. Right. So the answer for the 20th question is number 4. Then we'll move to the 21st question. So throughout the discussion, if you have any questions, you can ask, right? Right. So again, calculation and also very general question. ගොඩක් වෙලාවට එන ප්‍රශ්නයක්. The p value කියන එක. සහ ගොඩක් වෙලාවට contradictions එහෙම තියෙන question එකක්. Especially if you are going to use computer software for doing statistical analysis, you have to work with p values. හරි. ඔයාට p values එක්ක තමයි ඉස්සරහට වැඩ කරන්න වෙන්නේ computer applications පාවිච්චි කරනවා නම්. Right. Let's read the question. When the mean of the normal distribution is tested as a two-tailed test, the value of z was obtained as z equal 1.4. The p value of the test is, so very easy one, right? They just give us the z value, that is 1.4. So we know that p value is the maximum probability committing to accepting our null hypothesis. So therefore we have to calculate the probability of z greater than 1.4. So we need to calculate this probability. So if we consider the z distribution, in the middle 0, then 1.4 is here. So if you find the value, probability value corresponding to the z value 1.4 in your z table, you may have 0.4192. So p value is, if you want to calculate p value, you need to consider this part, right? Why? Because you need to calculate the probability that is greater than the z greater than 1.4. So it means greater than means right hand side part. Therefore you need to take 0.5 and you need to subtract 0.4192 from 0.5. So the answer is 0.0808. But this is not the p-value in this case. Why? So this is very important. So when you are doing a one-tail test, if you are doing a one-tail test, you allocate entire alpha for a one side. Then you compare the alpha with p-value as it is. If your hypothesis test is a one-tail test. But if you are going to do a two-tail test, this is very important. Two-tail test here two-tail test. What happened? Now you divide your critical region into two parts. It means you allocate alpha divided by 2 here, alpha divided by 2 here. So now you need to compare your p-value with alpha divided by 2, not with alpha. It means if you compare with alpha divided by 2 with p means if you want to compare with alpha, what you need to do? You need to consider twice of p. That is the p-value of the two-tail test. That is the p-value of the two-tail test. So therefore, you have to double or multiply by 2 this answer. So if you multiply by 2, the answer 0.808, then the answer is 0.1616. It means second one. So that is the story of p-value, right? p-value එක එහෙමයි calculate කරන්නේ one tail test එකක් නම් as it is probability එක calculate කරලා එන p-value එක තමයි ගන්න. But if we are doing a two tail test, then you need to double the probability value. Then you have the p-value. Right. So that is 21st question. So the answer is second one. Then the next question, that is 27. Sorry, 22nd. Yes. So again, you need to find the correct statement. So which of the following statement is true? A test statistic cannot have parameters. So actually it is correct. Because if you consider the test statistic as an example, consider the test statistics like this: x bar minus mu naught divided by sigma squared over square root of n. So here not squared, sigma over square root of n. So here normally the equation is like mu, but when you are doing the analysis, here you take it as mu naught, right? Not as mu. Because if there is a mu, you can't never calculate test statistic value because you don't know mu. හරි. දැන් මෙතන mu කියන value එක තිබ්බනම් ඔයාට කවදාවත් මේ test statistic එක කැල් කරන්න හම්බෙන්නේ නැහැ. ඇයි? ඔයා mu දන්නේ නැහැ. mu දන්නේ නැති නිසානේ hypothesis test එකක් කරන්නේ. So if you know the mu, there is no meaning of doing hypothesis test. The thing is you don't know the value for mu. So therefore you assume mu might be this hypothesized mu naught. So therefore a test statistic cannot have parameters. It is correct. Test statistic එකක parameter තියෙන්න බෑ. මොකද parameter අපි දන්නේ නැහැ. Parameter අපි දන්නේ. Right? So therefore first one is correct. First one is correct. Then the p-value for a test is calculated under the assumption that the alternative hypothesis is true. That is false, not the alternative hypothesis. Actually, we calculate the p-value or we calculate a test statistic assuming that our null hypothesis is true. අපේ null එක තමයි නිවැරදි කියන පදනමින් තමයි අපි p-value එක calculate කරන්නේ. So therefore, second one is also incorrect. The sampling distribution of a test statistic is decided under the assumption that the alternative hypothesis is true. This also false. Not the alternative hypothesis. Always we make the sampling distribution based on the null hypothesis. Null එක මත තමයි අපි හැමතිස්සෙම sampling distribution එක decide කරන්නේ. Therefore, we say our null hypothesis should be a simple hypothesis නේ. අපි එහෙමත් කියනව නේද? ඇයි? අපේ null hypothesis එක simple එකක් වුණ නැත්නම් අපිට test statistic එකට distribution එකක් identify කරගන්න බැරි වෙනවා. So therefore, our null hypothesis should be a simple hypothesis as well. Then the fourth one. So third one is also incorrect, right? The fourth one, the observed value for a test statistic is called a critical value. So that is wrong, right? Critical value is the value that separate the critical region and the acceptance region. That's how we define a critical value. Ne? Critical value එකෙන් තමයි වාගේ acceptance region එකයි critical region එකයි කියන දෙක වෙන් කරන්නේ. Test statistic එකට observe කරන value එක ඉතින් test statistic value කියන තමයි අපි කියන්නේ. ඒකට අපි critical value කියන්නේ. Critical value is the value that classify acceptance region and the critical region or rejection region. නේ. Rejection region එකයි acceptance region එකයි වෙන් කරන තැන තියෙන value එකට තමයි critical value එක කියන්නේ. So therefore, fourth one is also incorrect. The probability of accepting the correct null hypothesis is called the power of the test. It is also wrong. The probability of accepting the correct alternative hypothesis is called the power of test. නේද? Alternative hypothesis එක correct වෙලාවෙ ඒක accept කරන එක නම් power of the test. සාමාන්‍යයෙන් අපි null hypothesis එක correct වෙලාවෙ ඒක accept කරන එකට එහෙම විශේෂ නමක් කියන්නේ, but it is the 1 minus alpha. So therefore, fifth one is also incorrect. Therefore, only the first one is correct. So it is not much difficult, right? Okay. Let's move to the 23rd question. A company is ordering a large lot of items, letting P denotes the probability that an item is defective. The company decides to test the null hypothesis H naught, that is P less than equal 0.1. If H naught is rejected, the company returns the lot of items while it retains the lot of items if H naught is not rejected. What occurs if it commits a type 2 error? So if you know the definition of type 2 error, so there are two types of error. Yeah. In hypothesis testing, there are two types of error. One type 1 error and type 2 error. So in type 1 error, what we do? We reject correct null hypothesis. And in type 2, we reject correct alternative hypothesis. So what is the correct alternative hypothesis? Correct alternative hypothesis means H naught is less than 10% or less than 0.1. So therefore, alternative hypothesis should be more than 10%. නේද? H1 වෙන්න වෙන්නේ නම් අනිවාර්යයෙන් මේකනේ. මෙතන less than ගත්තොත් එහෙම H naught විදියට greater than 0.1 තමයි alternative hypothesis එක වෙන්නේ. එහෙනම් ඒක correct වෙන්න ඕනේ. ඒක හරි. ඒ වෙලාවේ මොකද කරන්නේ? අපි h not accept කරනවා. එහෙනම් අපි lot එක retain කරනවානේ. ඒ කියන්නේ අපි accept කරනවා කියන්නේ. So the company retains a lot which has more than 10% of defective items. So it is easy, right? If you know the meaning of type 2 error means we accept the null hypothesis when the alternative hypothesis is correct. So here alternative hypothesis is p greater than 0.1. p දශමයකට කියන්නේ 10%කට වඩා වැඩියෙන් defective items තියෙනවා කියන එක තමයි h1 alternative hypothesis එක. ඒක ඒ වෙලාවේ අපි මොකද කරන්නේ? plot එක retain කරනවා. So the answer is second one. Answer is second one. Right? අනිත් එකක්වත් අදාළ වෙන්නේ නැහැ. type 2 error එක හරියට define කරගන්න පුළුවන් නම් තාට හරි උත්තරේ මේකේ select කරගන්න පුළුවන්. Right. Then last two questions in the MCQ paper. So I will move to the 24th one. So again, you have to check whether A, B, C statements are correct or incorrect regarding the chi-square test of independence. So in hypothesis testing, there are two special cases in your syllabus as chi-square test and analysis of variance. නේද? ආගේ syllabus එකේ තියෙනවානේ chi-square test එක තියෙනවා. වෙනම area එකක් විදියට analysis of variance. ANOVA technique එකක් තියෙනවා. වෙනම concept එකක් විදියට. So this is related to the chi-square test of independence because there is another test that is called chi-square test for goodness of fit. නේද? එම test එකකුත් තියෙනවානේ goodness of fit එකට. මේක independence එක ගැන. Let's consider the A. The null hypothesis states the two variables are statistically dependent. So normally in chi-square test of independence, in the null hypothesis, we say there is no relationship between interested variables. නේද? අපි මොනවා හරි interest කරන variable දෙක අතර relationship එකක් නැහැ කියලායි අපි කියන්නේ. relationship එකක් නැහැ කියන්නේ ඒවා statistically independent. statistically dependent කියන්නේ relationship එකක් තියෙනවා කියන්නේ. එහෙනම් null hypothesis එකේ කියවෙන්නේ නැහැ two variables are statistically dependent here. But in statement B, it is correct because the null hypothesis states that two variables are statistically independent. So normally we say there is no relationship. Or if we consider two variables like gender and political preference is independent from the gender. එහෙම කියන්න පුළුවන් නේද? කියන්නේ දේශපාලන කැමැත්ත political preference එක මේ gender එක කියන එකෙන් independent. ඒක සම්බන්ධයක් නැහැ. That is H naught. And also, so B is correct, right? And C, the test statistics follow a chi-square distribution with R minus 1 into C minus 1 degrees of freedom. It is also correct. Ne? R කියන්නේ number of rows. C number of columns. So number of rows minus 1 into number of columns minus 1. So that is the degree of freedom for the chi-square test of independence. So C is also correct. So therefore, only B and C are correct statements. A is an incorrect statement. So therefore, for the 24th question, fifth answer is the correct answer. So normally, chi-square test related questions are not much difficult, right? You can limited concepts ටිකක් මෙතන තියෙනවා ඔයාලගේ syllabus එකේ. So therefore you can do, and in each and every year you can find a question from the chi-square test either from independence or goodness of fit. ඔය දෙකෙන් එකක එන්නත් පුළුවන්, දෙකෙන් වෙන්නත් පුළුවන්. ඒ නිසා chi-square test එක සම්බන්ධ question එකක් බොහෝ වෙලාවට MCQ ප්‍රශ්න පත්‍රෙත් ඒ වගේම second part එකෙත් තියෙනවා. So the last question in the model paper that we discuss or that we are discussing, let's see. Most probably it is related to the ANOVA. Yes, it is about ANOVA. It means analysis of variance. So in an analysis of variance table constructed to compare the mean scores of 4 teaching methods, the between teaching method sum of squares was 42 and error sum of squares was 60 with 30 degrees of freedom. The null hypothesis should be rejected at 5% significance level since the value of test statistic blah blah. So there are 5 answers. So actually this is very interesting question because there are 2 values, right? First value is the test statistic value and the second value is the critical value. Critical value එක තියෙනවා. ඔය critical value එකයි test statistic එකේ value එකයි දෙක compare කරලා අපි decision එක ගන්න. But you can notice that the critical value එක සාමාන්‍යයෙන් පිටිපස්සෙන් තියෙන්නේ නේ. මේක critical values උත් වෙනස්. So therefore actually no need to consider about the test statistic value. Test statistic එකේ value එක ගැන worry වෙන්න ඕනේ නැහැ. You need to consider only the critical value. Right? Critical value එක හරියට දන්නවනම් ඔයාට හරි උත්තරේ හොයාගන්න පුළුවන්. Right? So when you are doing some MCQs, so be smart. හරි smart වෙන්න ඕනේ. සමහරක් වෙලාවට ඔයාට ඒ උත්තරේම එකපාර ගන්න බැරි වෙන්න පුළුවන්. නමුත් දීලා තියෙන උත්තර පහ දිහා බලලා අදහසක් අරගෙන ඔයා දන්න method එකක් apply කරන්න පුළුවන්. So here I just use how to calculate the critical value or the table value for a given analysis of variance. So you know that we use F distribution and we consider alpha level and first degree of freedom, that is first degree of freedom k minus 1 and n minus k. So here what is alpha? Alpha given as 0.05. K means number of populations or number of samples or number of treatments. So here you have 4 different populations because there are 4 different teaching methods. So therefore 4 minus 1, that is 3. Here 4, right? And the error degree of freedom, right? So this is the error degree of freedom. This is error degree of freedom and it was given as 30. So you just need to find the F value in the F table at 0.05 alpha and the first degree of freedom is 3 and the second degree of freedom is 30 and the value should be 2.92. That's it. So you can find first one is the correct answer. Even you can't look at anything regarding the test statistics. Only you need to consider about the table value. Table value එක දිහා විතරයි ඔයා බලන්න අවශ්‍ය. Critical value එක දිහා විතරයි ඔයා බලන්න අවශ්‍ය. Right? So that's all about the MCQ in your model paper. So the time is 5 and I think you all are joining in the session from 1 p.m. I think. So altogether 4 hours you spend with the subject. And actually I'm not going to discuss the essay paper, but I will give you answers. I will share you answers because with the minimum time. And also even with the essay paper, we have some choices and also you can do with the answers. You can practice with the answers. If you have any questions, you can ask. So about the MCQs, if you have any questions, we can take some time. If you have any questions to discuss. Otherwise, we can wind up the session for today. So looking there is no any questions. Yes, I will also upload the answers of the MCQs as well, in addition to the answers for essay questions. So it is better to write answers for essay questions and check your answers with the answers given by us. හරි. ඔයා උත්තර ලියලා ඔයාගේ උත්තර ලියලා ඔයා check කරන්න අපි දෙන උත්තරත් එක්ක ඒවා match වෙනවද කියලා. එතකොට ඔයාට හොඳයි. right. ඒක තමයි මොන හරි subject related දෙයක් තියෙනවා නම් දැනගන්න. කතා කරන්න. මගේ contact number එක සමහරකට ඔයාලට ඇති access. සහ නැත්නම් අර අපේ WhatsApp group එකක දැන් ඔයාලා join වෙලා ඉන්නවා. ඒක through ඔයාලට පුළුවන් මොන හරි වගේ දෙයක් අවශ්‍ය නම් දැනගන්න අපිට share කරන්න. බොහොම පොඩි කාලයක් තියෙන right. So you have a very limited time, right? So therefore work hard, right? ගොඩක් මහන්සි වෙන්න. Yes, so I will give my contact number, right? You can contact me for your questions in relation to the subject and subject matters. So work hard and invest the limited time for your studies in these days. මේ දවස් ටිකේ වාගේ මේ තියෙන limited time එක මේකටම වෙන් කරගන්න පස්සේ පුළුවන් අනිත් දේවල් කරන්න. හරි. මට හැම ලෙෂර්ලි ඉන්න time එකක් හම්බ වෙනවා මේ වැඩේ හරියට ඉවර කරගත්තයින් පස්සේ. ඒකට I wish you all the very best for your future wishes, your future career paths, universities, යයිවා academic වැඩ ඉස්සරහට කරගෙන යයි, higher education වලට යයි. ඒ හැම තැනකටම මගේ wish එක ඔයාලට දෙනවා. වැඩ ටික හොඳට කරගන්න. So that's it about the today's session. Any comments? Otherwise we can wind up the session. Okay.
Thank you so much, sir. This brings us to the end of our seminar. Let me take this opportunity to thank our lecturers for gracing this event with their presence and valuable contribution. Thank you to all of you who participated. We hope completion of your examination, and we wish you all the best for your future endeavors. Thank you. Have a